formal definition of a set is something we don't do here, but I'm going to give you an intuitive definition. So a set is just a collection of objects. So let me write that down. A set is a collection of objects right, so and the objects in a set are called the elements of that set. I apologize in advance for my handwriting. Actually, I can't really apologize in advance because I already started writing, but I apologize in advance for my handwriting from this point through the rest of the year. Yeah? So, a set are called the elements of that set. And so, for example, so here's an example. If you take S to be, and the way, there are a couple of different ways we can write sets down. We'll talk about the most elementary one first. You can do something like this. So let S be the set consisting of 1 and 2 and the letter H, okay. And Vusumzi. This is the class rep he gets to appear in the first example of the course. So there we are. So there's a set, right? So that set has 4 elements. Or rather, the set S. Yeah? Oh my goodness, okay. What I wanted to do actually was delete. Okay, so there we go. Because that wasn't the word set, it was just something which started with the intention of being the word set and it went off in a different direction. So the set S has 4 elements. Right? So 1, 2, capital H, and Vusumzi. So a set is a collection of things, and you're probably used to seeing sets as being a collection of numbers. So 1, 2, 3, 4, 5, or whatever. But sets can contain all sorts of things, and this is just as valid a set as any other set you've seen. Yeah? You might think it's weird because look, there's 1, 2, and then there's H and Vusumzis in the set. It's a valid set. It's a valid set. As another example, so there's an example over there. Here's another example. So if we say So that set which we write down with this funny looking Z is called what? The integers, yeah? So this is the integers. And we've introduced a little bit extra in our set notation. Now what we've done is we put these 3 dots. 3 dots, that's the standard, not 4 dots, not 2 dots, not 12 dots, 3 dots. 3 dots in mathematics indicates a pattern. Right? So if we have something like this, then the idea is that by looking at the rest of the information given, which is here -3, -2, and so on up to 3, from that you should be able to then deduce what the rest of the pattern looks like. So this indicates that this goes on from 3 to wherever, up to infinity, and from -3 down to -infinity. Yeah? So the dots indicate a pattern. Okay, so that's called the integers. That's Z. And so one thing we notice about these 2 sets, we compare them, well, I mean, lots of different things to notice about them. So the set S over here has 4 elements, and how many elements are in Z, in the integers? Yeah, an infinite number. So this set over here is a finite set. And this set over here is an infinite set. So this immediately sets up into 2 different classes. So here are some other ones. If we have, no, let me introduce that one later. Let me say something else first. Okay, so 2 sets. A and B, And by the way, so I've been doing this as I've gone along. Hang on. So the two sets A and B are equal if they have exactly the same elements. Right, so two sets A and B are equal if they have exactly the same elements, and so we write that. I'm just going to put this as A equals B. So this is what it means. You know what it means for two numbers to be equal, right? It just means they're the same number. So two sets are equal. If we give this a definition now. Right? So this is pure mathematics. So pure mathematics is all about definitions, and then from definitions you then get theorems and so on and so forth. So here's the definition of two sets being equal. Two sets are equal if they have exactly the same elements. So in other words, i.e., every element of A is an element of B, and every element of B is an element of A. Yeah. Yeah. Okay. So that's a good question, and I should have said something about that already. So thank you for bringing it back to my attention. So the question is, if you have a set, can you list the elements? If you list the elements in a different order, are they the same set? Yeah. The answer is yes. So the only thing that matters when you're looking at two sets is which elements in the set, which elements are in the set. The order in which the elements are listed does not matter. So let me just make a note of that actually. So the order in which the elements of a set are listed does not matter. So for example, if you have the set A, which is well, let me go back to my favorite set over here as well. So let me go. So there's S. You can copy and paste this as well if you want. You don't have to write it out again. Oh, you can't? Oh, sorry. So this is S. And let's introduce a new set, which is T, where we have H, and then 2, and then Vusumzi, and then 1. Those two sets have the same elements, right? They're listed in a different order, but the order in which you write the elements of a set does not matter. Yeah. Okay, so the question is, what happens if the 1 is repeated in S? The answer to that question is it can't. So no, it's a good question, because it brings up the following distinction. So in a set, you can't have something repeated. Right, so each element gets listed only once. Something like a set where you can repeat elements is called a multi-set. But in a set, the ones we're considering over here, each element can only be written once. So if you find out that you've written something down twice, you can just cross one of them out. So each element is listed exactly once. So these two sets over here, S and T, look, every element of S is an element of T, and every element of T is an element of S. These are the same set, right? These two sets are equal to each other. So we have here S equals T. And while we're at it, you know this notation here, by the way. So we use the notation like this to indicate that the element, well, that small a is an element of big A. Yeah? So this funny little symbol over here, which is not actually quite an E. It's more like a C where you've added a horizontal line in the middle. So that thing over there we use to indicate the fact that small a is an element of big A. Yeah? So just before I give an example, I mean this is very simple, but I'm going to give an example anyway. Let me just mention, there's another thing which you should get out of this is the convention that we're going to use in this course, and this is a convention which is used in many parts of mathematics, is that when you have a set, it's written with a capital letter. Right? So the name of a set is usually written with a capital letter, and then, you know, if you're referring to an arbitrary element, an unspecified element of a set, not a specific element like Vusumzi or capital H, but you're just saying, you know, let X be an element of this set here over here, then that element of the set is usually written with a small letter, right, in lowercase. So names of sets are usually written as capital letters, and small elements of sets are usually written as small letters. So okay, so for example, there we go. There's S again, and so what we can do over here is we can actually say, well, 2 is an element of that set, but 3 is not an element of that set. And I should hang on, no. I forgot about the cut and what am I doing? Okay, so let me just write that again, but this time with less writing. Although by the time I finished doing that, it probably would have been less effort to just go the first way and just write the whole set out again. So 2 is an element of that set, and 3 is not an element of that set because 3 is not listed amongst the elements of that set. And so there you go.